Now we will talk about the complex numbers. So whenever we have the questions or in the form of ax squared plus bx plus c, you know that it is called the quadratic form or quadratic equation when it is equal to 0. Now to solve the quadratic equation we can use the factorization or quadratic formula. And when we use the discriminant, which is we call that b squared minus 4ac, if discriminant is greater than 0, we have real and different solutions like x1 and x2. If the discriminant is equal to 0, we have just one real solution. And whenever we have discriminant is less than 0, we have complex solutions. And it means that the graph of the parabola does not cut the x-axis. So there is no x-intercept. Whenever we have the complex roots, complex solutions, we have to know some basic definitions. In mathematics or in calculus, we can say I squared is equal to -1, so I is equal to square root of -1. So whenever you see somewhere square root of -1, you should say that this is directly number I. So for example, if you have square root of -5, this is equal to root -1 times root 5. So this is equal to root 5 times I, we can say. And for I, we have to know also I to the power of 1, which is equal to I itself, I to the power of 2, which is I squared, which is equal to -1, and I to the power of 3 is I squared times I, which is -1 times I, which is negative I, and I to the power of 4 is equal to I squared times I squared, which is positive 1. And then I to 5, I to 6, I to 7, by using the modular arithmetic mod 4, we are calculating. For example, I to 5 is equal to I to 6 is equal to I to 2, which is -1, I to 7, which is equal to I3, so it is equal to -I, something like that. But today we are not going to deal with them. We will just talk about how to find the quadratic equations when the discriminant is less than 0. You know that x squared plus 9 is 0. To solve this question, we can say that x squared is equal to -9. And then, if we take the both sides the square root, root x squared is equal to root -9. So we can say that absolute value of x is equal to plus minus root -9. But root -9 is not a real number. So we have to express it in the form of -1 times positive 9. And then it will be plus minus. Instead of root -1, we can say that it is equal to I times root 9 is 3. So result is plus minus 3I. So x1 is equal to -3I and x2 is equal to positive 3I. We have two solutions. By the way, by using the quadratic formula, we can say that the discriminant, which is b squared minus 4ac for the given question, you know that for the given question a is 1 and b is 0, which is coefficient of x, and c is here 9. So what will be b squared? It will be 0 squared minus 4 times 1 times 9, which will be -36. Since this is -36, there is no real solution. No real solution. Okay, we have complex or imaginary solutions. Complex solution. In order to find a complex solution, you know x is equal to, or first x is equal to -b minus root delta over 2a, which means -b, since b is 0, it will be -0, minus root delta, which is discriminant over 2 times a, 2 times 1. So it will be -0 means 0, so no need to write. It will be negative times root -1 times root 36 divided by 2. And then root -1 is I, so it will be -I times root 36 is 6 divided by 2. which will be, if we simplify, it will be negative 3i. So as we did it before, since this is negative 3i x1, you know that x2 is equal to, just we put it here plus, so that means that when we put it plus, when we put it plus, it will be just positive. I mean, instead of this negative, it will be positive, so x2 will be positive 3i. x1 is negative 3i. So by using quadratic formula or by using a normal way, we did. Now let's go for the second question. So 9x squared is equal to negative 25, and then x squared is equal to negative 25 over 9. If I take the square root of both sides, it will be absolute value of x is equal to plus my absolute value of x is equal to square root of, I can say that, negative 5 over 3 squared, and then x is equal to plus minus root negative 1 times root 5 over 3 squared. So x is equal to plus minus root negative 1 will be I times 5 over 3 squared will be 5 over 3. So the first x is equal to negative 5 over 3i, and the second x is equal to positive 5 over 3i. Or we can solve the question. A is here 9, B is here 0, C is here 25. So the discriminant, which is delta, B squared minus 4 times A times C. So it will be, actually B is here 0. So 0 minus 4 times 9, which is 36 times 25. It is clear that less than 0. So we have complex solutions. Okay, and in order to find the complex solutions, we can use that x is equal to negative b plus minus root delta over 2a, but I am not doing one more time, so this will be answer. Okay, now the other question. Now here, in order to solve this question, I can say that the same way, but directly I will use formula. A is 1, B is 1, and C is also 1. So delta is equal to B squared minus 4 times A times C. And then it will be 1 squared minus 4 times 1 times 1. It is clear that 1 minus 4, which is negative 3, less than 0. So we have complex solution. Complex solutions. So we do not have real solutions. So no real solutions. So complex solutions means that root, it's not on the x-axis, on the real axis. That means the function is not cutting the x-axis. It means that it is above the x-axis or the below the x-axis. In order to find the roots, we can use the formula, which is negative b plus minus root delta over 2a. So the first x will be, I can say that negative 1, since b is 1, and minus root delta, which is negative root 3, 2 times a. So it will be negative 1 minus I times root 3, since you know that negative root 3 could be written as negative 1 times this, and it will be I times root 3 or root 3 times I, same. And then divided by 2. So this is the first root. And the second root will be, directly before the I we will put plus, but just to show you, negative b plus negative root 3 2 times 1, which will be negative 1 plus I times root 3 over 2. That's it. What about this question? Can you tell me what will be ABC? I hope you said A is 1, B is negative 2, and C is 2. So delta is B squared minus 4AC. So delta is equal to negative 2 squared minus 4 times 1 times 2, which is 4 minus 8, which is negative 4, which is less than 0, no real roots. So we have complex roots. We have complex roots. So in order to find this, the first root is equal to negative b minus root delta over 2a, which will be negative, so b was negative 2, let's use the parentheses, it's better, minus the delta which we have calculated, negative 4, 2 times a is 1, so negative and negative will be 2, minus, now root negative 4 could be expressed by negative 1 times square root of negative 1 times square root of 4, so it will be I times root 4 will be just 2 divided by 2. If we take 2 common parentheses, 1 minus I divided by 2, and then if we simplify, 1 minus I. So when x is 1 minus I, the other x will be 1 plus I. But to see this, negative plus 2a, so it will be negative 2 plus root negative 4 over 2 times 1. So it will be 2 plus root negative 4 divided by 2, but root negative 4 will be 2 plus 2 times I divided by 2. If we simplify by 2, it will be 1 plus I. So one of the roots is 1 minus I, and the other root is 1 plus I. And what about this question? Here we don't have the equation, but we have the fraction, and the denominator is not real number. So how can we make this real number? If I multiply this by its conjugate, so what was the conjugate? Let us remember. Conjugate was this. When I have a plus b, its conjugate is a minus b for the numbers. For example, if I have root 2 minus 3, its conjugate root 2 minus 3. Now, for the complex numbers, the conjugate will be just this one. I mean, a plus bi, if you have, the conjugate will be a minus b times I. For that reason, 1 plus I, 1 minus I say. So, if I multiply the numerator and the denominator by the conjugate of the denominator, which will be, if we distribute this, 2 times 1, 2, 2 times negative I, negative 2i, 3i times 1, 3i, 3i times negative I, negative 3i squared, divided by 1 times 1, 1. Actually, whenever you have a plus b and a minus b, this is a squared minus b squared directly. But now I want to do it. 1 times 1, 1, 1 times negative I times 1, I, and I times negative I squared. And then here, let me change the color. So here I can say that easily, since I squared is negative 1, so when I will see I squared, instead of this, I will put negative 1. So 2, negative 2i, positive 3i, just I. Now negative 3 times I squared, so I squared is negative 1. And then positive I, negative I, simplify, 1 minus I squared. I is negative 1. I squared is negative 1. So final result will be 2 plus I plus 3 divided by 2. So it will be 5 plus I divided by 2. Or how can we write this? It is 5 over 2 plus 1 over 2i. So this is directly equal to 5 plus I over 2. And this is called the real part, and this is called the imaginary part, 1 over 2. Just I want to give you one practical rule. A minus bi times a plus bi, it's always a squared plus b squared. So in my question, a plus bi and a minus bi, a squared plus b squared. But don't forget, b is in front of the I. What do we have in front of the I? So this is A is 1 here, and B is here also 1. So it will be 1 square plus 1 square. So it will be 1 plus 1, which is 2, as you've seen here in the denominator. Now let me continue here. So 2 plus I, which is the conjugate, so it will be 4I times 2 plus I divided by 2 minus I times 2 plus I. If I use the practical rule, directly denominator will be 2 square plus, in front of the I you have 1, so 1 square, and numerator 4I times 2, 8I. 4I times I will be 4I squared, and I know that I squared is negative 1, so 4 times negative 1 divided by 4 plus 1, so final result is 8I minus 4 divided by 5, or you can say that negative 4 over 5 plus 8 over 5I. Okay, we write the first the real part, which means without I, and then we write with the I. That's it. If this is not clear the practical way, I can also explain to you. Here, let me change the color. So 2I minus I, how will be 2 times 2, pardon, so the color is probably white color. 2 times 2, 4. 2 times I, 2I. Negative I times 2, negative 2I. Negative I times I, negative I squared. Which means negative 2I, positive 2I, 0. 4 minus, instead of I squared, if I put negative 1, so result will be, as you've seen, 5. What we said before also. And what about if we have just I? Just I multiply. So we are not using the conjugate, just I. So 3 minus 2I multiplied by I divided by I times I. And so it will be, if I distribute, 3I minus 2I squared divided by I squared. And 3I is just leave it like that. Instead of I squared, put it negative 1. So put it negative 1. So final result 3I plus 2 over negative 1. So you can say that this is negative 3I minus 2, or negative 2 minus 3I, we can say. Okay, that's it. Now finally, if we do this, 3 times 3, 9. 3 times 4I, positive 12I. Negative 4I times 3, negative 12I. Negative 4I times 4I, negative 16I squared. So 9, simplify, negative 16. Instead of I squared, negative 1. So 9 plus 16, which is 25. Or directly, using the rule A minus BI times A plus BI, if we have this form, so A is here 3, so it was A squared plus B squared, the formula, so it will be 3 squared plus 4 squared, so it will be 9 plus 16, which is 25. So if this is difficult, forget about this, it's not important, just use the classical way. And when we use the practical way, if we have conjugates, don't forget A minus BI, A plus BI. If we don't have conjugate, we have to use classical way, so which is here. 2 times 3, 6. 2 times 4I, 8I. Negative 7I times 3, negative 21I. Negative 7I times 4, negative 28I squared. And then 6, 8I minus 21, so it will be 8, 10, so 13, I think 13I, and 28 times, instead of I squared, put it negative 1, so 6 minus 13I plus 28, so 34 minus 13I is the final result. I hope you understood. If there is any question, you can put some comments to the YouTube video, I mean there, in the given part, I mean in the YouTube, in the chat box, or the comment parts. If there will be any question, you can ask me, you can email me. All the best.